Welcome and thank you for joining us today for our webinar, Moving GIS to Cloud, with the focus particularly on the data side of things, specifically any preparation and migration of spatial data. Before we begin, the session will last about 45 minutes and we'll be sending out the recording afterwards. Time permitting, we'll have a question and answer session at the end. There's a question panel on your right. Please feel free to type and submit your questions at any time throughout the webinar today, and we'll pick those up at the end. Also, we'd be grateful at the end today if you could complete our short survey, which will pop up, and that will help us with future webinars. Finally, just to let you know, you're in listen-only mode, so we can't hear you. So, to introduce us today, my name is Demelza Potter. I work in the business development team here at CAD Corp, and I predominantly work with our local and central government customers, helping them make the most of their GIS investment. My co-presenter is Simon. Over to you, Simon.
Yeah, thank you, Demelza. Good morning, everybody. My name's Simon Parker. I'm the pre-sales team leader at CAD Corp, and this morning I'll be demonstrating just some examples of how you can streamline your data, some of the considerations for checking that your data is fit for purpose, and then just some of the options that are available for migrating that data into the cloud.
Thanks, Simon. We're just going to turn our webcams off for the moment just to reduce the bandwidth and improve performance, and get kicked off on today's agenda. So I can see from those of you who have joined us today, we've got a complete mix of CAD Corp and non-CAD Corp customers. So I'll start with a bit about what we do at CAD Corp, and then I'm going to run a quick poll to find out a bit about your organisation's current use of cloud geospatial data. We'll look at the benefits of cloud migration in general before looking at the data side of things in more detail, as there's some specific data considerations I'd like to discuss. Then over to Simon to demonstrate some tools to help that data migration. And finally, over to your questions. So a little bit about us at CAD Corp. We're UK based and focus on the development and delivery of our GIS applications. We work across various sectors, these on screen and more. CAD Corp SIS, or Spatial Information System, is our suite of GIS products covering WebMap and mobile and desktop applications. All products provide interactive and dynamic access to geospatial data, and CAD Corp SIS can either be hosted in the cloud and managed there, or indeed installed locally. Moving to the topic of today's webinar, data in the cloud, I said I'd start with finding out a bit more information about you. So I'm just going to launch a poll in the background. You should be able to see that. Do you currently use cloud geospatial data services in your live applications? So yes, no, and don't know, unsure. I'll just leave that a few seconds and then let you know what the results are. So we are roughly about 25% yes, 70% no, 5% unsure. So quite a few of you on the line don't yet use any of cloud geospatial data services. So of those of you who do, the 25, or it's just gone up to 26%, what it would be good to know is of those services, do you use any of these for background mapping, like your Ordnance Survey OS APIs, Google Maps, APGB data? Do you use it for business data, i.e. your planning applications, assets, incidents, etc. in the cloud? Do you use open data like that from the Environment Agency and other government organisations, or commercial data that you pay for? Okay, so 92% of you use background mapping, 69% business data, 56% open data, 30%, the remaining keeps changing, the remaining percentage commercial data. So it is quite widespread, the highest number probably, as I'd expect, being the background mapping side of things. Okay, that's interesting. Let's close this and carry on. Okay, so here are some current CACOP Cloud customers. All of them consume CACOP, cloud geospatial data in some way. I had to make these images smaller to fit them on screen, so there's a constant expansion of customers actually migrating to the cloud. So I guess my first question is, why did these organizations choose the cloud? Well, basically there are numerous benefits. Now, I've stolen this slide from a previous webinar by my colleagues, but I thought it was useful just to run through the reasons. And the main reason why the package includes a lot: upgrades, background map updates, admin monitoring and support, backup and disaster recovery options. Right at the bottom, I thought today we'd take a different angle, taking a look at specifically the data considerations alongside the benefits as such, to help you in your thinking. So there are 5 considerations we'll look at today, which should help you think about prepare and ultimately migrate your data to the cloud. These are auditing your data to find out what data you have, looking at the sources of data, asking yourself the question, is there a better data source? Is there a data sharing agreement in place? What level of security is required? And finally, how business data migration should proceed. So starting with data auditing, before moving any data, it's good practice to audit it so that you know what you have, and later you can make any decisions more easily on if and or when you might want to move it into the cloud. It's useful to have this information on screen about all of your data sets being utilised by your GIS, whether it's business, non-business, including your sort of OS data sets. And then finally, I guess following the data audit, you may want to look at and review the data source. In terms of your business data, you might want to ask yourself a number of questions. Will it be migrated to a spatial database? Probably. Will some of it remain as flat files? Quite possibly you might leave your raster data as flat files. Is the data fit for purpose? Does it need cleansing in some way? Is the data sensitive? Does it need, does part of it need hiding in some way? So in terms of background maps, could the data be sourced more efficiently? Traditionally, data management, having all the data on site, has been a job in itself for GIS officers and managers, and you might want to lighten the load by taking data directly from CACOP or third-party web services. Ordnance Survey APIs are available. The CACOP map data service, especially WMTS, is very popular. This is OS maps designed for web mapping. They're national data sets with master map updated by us on a 6-weekly basis, so you don't have to. And finally, you might want the master map vectors for snapping and editing too. Those can be delivered to any GIS client, again, updated by us on a 6-weekly basis, all coming to you from the cloud. So what I'm saying is there are options available. So coming back to data sharing agreements, if CACOP hosts a solution in the cloud, chances are we're going to need to process or handle your data in some way. Before we start hosting data on behalf of a customer, we're often asked to sign a data sharing agreement, or DSA. So what is this? It's a formal document defining the purpose of sharing data, what will happen, who's got responsibility and liability for what. Now, an example of this, which a lot of you will have come across, is the Ordnance Survey Contractor Agreement, but your organisation might also have its own data sharing agreement. These help to demonstrate compliance, important in terms of GDPR, and overall they're good practice. Moving on to data security, for the majority of customers, this means utilising Azure AD. Active Directory controls your access to files and software in a way that you don't have to log into each system. Azure AD does this in the cloud. It provides an authentication mechanism. So Azure AD will control access to any cloud software. And then on top of this, CAD Corp recommends a spatial database such as SQL, Azure, or PostGIS, where a database security model will only allow certain users or groups permissions to different tables once the data is in the database. Finally, coming back to your business data and how that might be migrated, there's no right way. Each organisation does it differently, slightly differently. You may just want to take it as it is, lift and shift it from one place to another, or you may be able to take the time to review each data set as it's moved. You may want to manually move or use tools to automate the process. And indeed, any order might depend on any departmental or project priorities. There may be reasons to duplicate or mirror data sets or even whole databases in the cloud. And CAD Corp provide a number of tools to enable data migration in these different ways. Okay, I'm going to swap across to screens to Simon, so that he can start his presentation. Simon's going to pick up on some of the themes that I've discussed and put into practice some of the tasks with the tools available. He's going to connect to different cloud data sources, clean and correct data, export data to a cloud database manually, as well as look at some automated uploads. Over to you, Simon.
Thank you, Demelza, and good morning to you all again. So yeah, sort of as Demelza just mentioned, I'm going to talk about some of the ways you can streamline your data and just show you sort of some of the techniques for managing your data migration to the cloud. So Demelza mentioned earlier that you can fit your data into two camps. So the first camp is probably that background mapping, which gives you that geographical context. And on screen at the moment, we're viewing some Ordnance Survey data, which you may be familiar with, and we're viewing that within the CAD Corp desktop software. And then the second camp to consider is your organizational data. So let's start with that sort of first camp, which is that sort of background mapping. And as I said, it's more than likely you're using Ordnance Survey mapping for your base map, and you'll be storing this data maybe in a combination of ways on your network, and perhaps in a spatial database like SQL Server. Now, there is nothing stopping you just migrating that data into the cloud and just sort of copying that storage setup that you currently have on your network. But there are opportunities to streamline your data holdings as you do move into the cloud. Now, one alternative is the Ordnance Survey Data Hub, which is a platform for basically accessing the Ordnance Survey data directly through an API. And the benefit of using their API is that you don't need to sort of download the data, you don't need to store it, and that also means you're not necessarily managing that Ordnance Survey mapping data holdings yourself. Now, it's really easy to connect to the data, and I'm going to show you sort of a quick example using the CAD Corp desktop application. Now, right in the top left-hand corner, we've got our Add Overlay wizard, and we use sort of a lot of wizards in our software just to make tasks like this, really easy to perform. And within this wizard, we've got our Ordnance Survey category, and this is where you can sort of access a range of Ordnance Survey sort of data sources via this wizard. And it also includes an option for the OS Data Hub, where in here you can access sort of dedicated wizards that support the features, the maps, and the vector tile APIs. Now, in order to access the APIs, you do need to register for an API key. In our software, we actually do provide one by default, but that will just give you access to the free open data only. But today, the key that I'm using will give me access to some of the premium data that's on offer as well. So I'm going to show you a quick example of connecting to the OS Data Hub, and I'm going to show you an example of the OS Maps API. And this API provides sort of background mapping for your project. So it's just served out as a WebMap tile service. And in the wizard here, you just simply choose which style of mapping you want to add. So that can be the light, outdoor, road, or leisure. So I'm going to choose the outdoor style today, click finish, and that data is added into my project. And we can see that they're listed on the left-hand side there. So the mapping is in my project, and at this small scale that we can see here around York, we are viewing the Ordnance Survey Zoom Stack product. But as we start to zoom into the map, and because I have a key which gives me access to premium data, as we sort of zoom in close enough, we can see that really detailed mapping. So this is the master map topography layer. So it's really easy to connect to the data, and it's just going to save you a ton of time, not having to sort of download, store, and maintain your own versions of the Ordnance Survey mapping in the cloud. Aside from sort of Ordnance Survey, you can also look for opportunities to streamline any sort of other third-party data that you might currently use within your organization. Just because more and more data now is being published out as an OGC web service. So that means you can just simply connect to the data using a URL. So if I go back to the Add Overlay Wizard and just show you a quick example. So we've got the OGC category here where we can connect to a variety of different web services. So I'm going to choose a web feature service in my example today. An example is from the British Geological Survey. So we simply add in the URL and that will allow us to connect to the data service. And then once connected, we can just see all the different data layers that they have made available. I'm going to choose this first one here, which is just some sort of bedrock geology data. I'm going to run through the rest of the wizard, and then that will then load in that particular data layer as a web feature service into my project. And I've now added that geology data that we can see here on the screen. So it's just another example of being able to connect to the data directly from the source without needing to sort of download and maintain a copy of the data yourselves. So let's now talk about sort of that second camp of data, and that's your organizational data. Now, before you do migrate your data to the cloud, as sort of Demelza mentioned, you should audit your data just to see what you actually got, and then decide what data you want to perhaps migrate into the cloud, because you may find you've got a lot of data that you perhaps don't need going forward, and it can just be archived. But once you've got that list of data, then you can perhaps consider two options for migrating that data. Now, you can manually migrate the data using desktop GIS, or you can use a tool to automate that process instead, or maybe perhaps just use a combination of the two methods. So I'm going to go into those methods in a bit more detail, and I'm going to show you sort of the manual approach to start with. Now, for those of you who are sort of familiar with the CAD Corp technology, one of our strengths is the support for over 300 data formats. So, you can grab your data, whatever format that might be in, you can drop it into our software and then use the technology to push it out into the cloud. So just to show you a very quick example, on my drive here, got a couple of different data formats. So you may have shapefile data, it could be sort of tab file data, KML, maybe even GeoJSON. So you can grab those files and drag them directly into the software and then use the manual process to export that data out into the cloud database. But before you migrate that data, you should perhaps maybe assess the quality of the data first, just to check that it's fit for purpose. And in my particular project here, I've got a layer, which is my brownfield register layer. And I want to migrate that data to the cloud. But before I do that, I'm going to check if there are any geometry or attribute errors in the data first. So I'm going to start with geometry first, and it is important that you check for any bad geometry in your data, because some databases won't store data that's not OGC compliant. So it may also provide or give sort of difficulties also using the data when you use the data in certain software applications. But in the desktop GIS, under the edit tab right at the top here, we do have a group of functions here that allow you to sort of clean and simplify data. So you could just load in the data into the software like I just showed you, run any of these tools to clean the data as a process, and then push the data into the cloud. But for the sort of benefit for you today, I'm just going to go into a little bit more detail and just show you how you can find and spot some of those errors. So at the top here, I'm going to open the query builder, which again, just another little wizard tool. And I'm going to query my brownfield register layer. And I want to find some bad geometry. Now, in our software, we do have an identifier, which tells us if geometry is good or bad. And what that basically means is, does that geometry conform to the OGC standard? And that identifier is called simple. And in our software, any geometry that is bad is just marked as a 0. If it's good, it's marked as a 1. So we can use this option here to find any bad geometry in my brownfield register layer. I'm going to select any of the items that match that query, click finish, and then right in the bottom left-hand corner, we can see that it's found one bad geometry in my data. So I'm now going to zoom to that particular feature, and I'll just zoom out on the map a little bit there. Now, just to help me sort of demonstrate the concept of cleaning data, I'm going to turn on a saved theme. So it's actually using that same identifier that I used for the query, but I'm using it to style the data. So the data is styled red if the geometry is bad, and if I just pan a little bit, if the geometry is good, we're just styling it there as green. So we've just got that visual representation of good and bad geometry. So let's now focus on this bad item. So looking at this particular feature, you may be able to identify what the problem might be with this one. So in the corner here, what you have here is the sort of polygon crossing itself. So that's called a self-intersection. And that means, because there's a self-intersection, it doesn't comply with the OGC standard. So we wouldn't be able to sort of export that feature as it is to the database. Now we could just report back to the data owner and maybe ask them to correct it. And they can just do that manually within sort of a GIS software. So they could perhaps rectify this. So if I just remove some of these vertices to remove that self-intersection, we can see we've cleaned the geometry. It's now shown as green. So that means it now meets that OGC standard. But if you do find you've got a data set which has got loads of errors, then perhaps manually changing them might not be the most efficient way, or you may just not have the time to deal with them. So if I just undo my previous changes, we could perhaps use some of the cleaning tools to clean the data instead. So if I go back to the edit tab, I'm going to select this clean option here. And in here, we've got this option here to remove self-intersection. So if I apply that to my data, click OK, we can see it's removed that self-intersection, and we can now see visually that the geometry is now good. Now, as I mentioned, there are other techniques available for cleaning geometry data, but I don't have the time to sort of go into them in detail today. But these options are described on our online help, and CAD Corp would provide assistance to you if you are sort of going through this process as well. So we've looked at the geometry. Let's now look at the attribute data in the table view. Now, for completeness, ideally, there shouldn't be any fields with any blank values. So you could use the query builder that I just showed you to maybe search for any empty fields in your data. Or in my example, I've actually got a completely empty column for my organization name. So I can use the fill column option here to actually add some data values into that column. And because we're sort of based in York, or this data is based in York, I'm just going to use the City of York Council as my organizational name. And then when I close these options here, we're going to apply that value to the whole overlay. We've now filled all of those rows with those details. You can also use that fill option there as well to perhaps find and replace spelling mistakes in the data as well. Now, it's also worth looking at perhaps incorrectly formatted data. You can, in fact, make formatting changes to the data when it's in the database, but you do also have the option within GIS software to format the data before you actually migrate it into the database. And one example here is this permission column here. So we can see that all of the text is upper text. So we can actually sort of reformat that with some functions within the GIS. So over to the left-hand side, I'm going to access the properties for my permission column. And then I'm going to use a function called sentence to properly format that data. So if I apply that to the column, we can now see we've got a better formatted column. So we've got a sort of leading capital and lowercase to follow there as well. You may also have a requirement to add new columns in the data as well before you migrate your data. So in this particular data layer, maybe a good piece of information to have is actually the area of the brownfield sites themselves. So if I go to the left-hand side of the screen, we can add a new column into the data. And area is actually sort of an internal property within the software. So I can call upon that area value, which is measured in square meters, click OK, and I've added that new column to the data, giving us the area of each of those brownfield sites. And we can even go a bit further because we can see we've got loads of decimal places there. Perhaps we don't need those amount of decimal places. So if I go back to the left-hand side here, go to the properties for my area column that we've just added, I can use another function which will allow me to round the data. So I'm going to round it to 2 decimal places, click OK, and we can see we've just tidied that data up a little bit more there as well. And then finally, you can remove columns of data as well. So in this example, this plan app reference column here and my notes column here are exactly the same. So why are we storing duplicate data within this data set? So we can perhaps right click on particular columns that we don't need anymore and remove them from the data. And also we can also rename columns as well. So you may get some sort of funky column names of data, and you may just want to change them to something more obvious before you migrate them to the database. So you can do that as well. So I can appreciate I'll probably just whiz through very quickly sort of several ways you can improve sort of the completeness and formatting of the data, but hopefully I've just shared some of the things that you can consider when evaluating the quality of your data. So this particular data is ready to go. So we now want to migrate it to the database in the cloud, and I'm going to be working with a PostGIS database today. So with my data ready, we're going to go to the file menu in the desktop GIS, and we're going to choose the export to server option and export to the PostGIS database. So my database is in the cloud. I've just called it cloud, and there'll be a requirement to enter some username and passwords because you'll need permission to be able to export the data to the cloud database. Now, if I run through the wizard to export my brownfield register data to the database, the layer is going to be called brownfield register in the database. Click finish, and I've now exported that data, and that data is now available in my PostGIS database, and that can be consumed by any software that can connect and consume data from that particular database. So let's just have a quick look at that data. So if we go back to the Add Overlay wizard, this time we're going to go to the database category, select PostGIS, and we're now going to connect to that cloud database where I've just exported that data. And once connected, we can see my brownfield register data is available in the database. And then before I load it within my mapping project here, I'm going to rename the layer. So we're going to call it brownfield register, and I'll just say cloud in brackets so we know it's from the cloud. Click finish, and we can see on the left-hand side in my layer list here, I've got that connection, a dynamic connection to my cloud database, and I'm reading or consuming that data within that project. And then very quickly, I could perhaps just copy across the styles from my layer into the cloud version so we can see that data there in SIS desktop there. So that was an overview of how you can assess and clean your data with a set of tools available within the desktop GIS, and then using the export function there to migrate that data manually into a cloud database. Now, the second approach I'm going to demonstrate to you is automated. And what we've got on screen here is the CAD Corp Extract, Transform and Load tool, or ETL for short. And this tool basically manages the upload of data to a cloud environment. Now, you could use this tool to perform a one-off import of sort of multiple data sets, or you can use it to upload data on a schedule. So, for example, you may have a business system which produces a daily file, which you want to push up into the cloud every day, so you've got sort of concurrent data available within your cloud environment. Now, there are loads of options available with this specific tool, and yeah, I just don't have time to explain them all today, but today I'm just going to focus on the upload mechanism. So in the tool, I've set up a schedule to upload 2 new files into my PostGIS cloud database, and these 2 files are some incident data in a shapefile format, and some planning application data in a tab format. And we can see within this dialog here, they're scheduled to be uploaded on a daily basis. Now, if we just look at the details of one of the data sets here, in here you can choose how frequently the data is uploaded, and you can choose obviously the time of day. So you may choose to do the upload during the middle of the night outside of sort of business hours. And then at the bottom here, we've got the credentials for connecting to the database. So here I'm going to be exporting the data to my cloud database. Now, I started the ETL service during my demonstration. So actually these 2 files have just been uploaded to my database in the cloud. And if I open up the event viewer on my machine and just refresh this log basically provides basically a log of the upload process, and we want to see an entry where it says, yep, 2 files have been successfully processed. So my 2 files have been successfully processed to the cloud. Now, instead of just returning back to the desktop GIS and just showing you those data sets in the desktop GIS, I'm actually going to launch the PostGIS database management tool, and that is available in the browser. And I've got a connection here to my database in the cloud. So this is my cloud database, and then under the sort of table tree here, we can see 3 data sets. So we've got the brownfield register table, which I exported manually via the desktop GIS, but we now have the 2 data layers, the incidents and the planning applications in the database as well, which I uploaded via the ETL tool. So that's the ETL tool, which can be used as an automated process to either upload sort of multiple data sets as either a one-time upload or as a scheduled task on a regular basis. And because the data is now in the cloud, and I sort of mentioned it earlier, it can be consumed by any software that can read the data. And this might include web mapping software like the CAD Corp SIS WebMap application. And for those of you who are sort of not aware of WebMap, WebMap is an application that enables you to access and analyze your GIS data via a web browser. And just like I showed you earlier, in the web mapping environment, you can also connect to the OS Data Hub API as well. So what we've got on screen at the moment is the OS Maps API, which is providing me my background mapping. And we've got the light style currently on the map. But if I go to the top right-hand corner, I've made available all the different styles. So perhaps I want to view the outdoor style from the OS Maps API. And then in terms of your actual organizational data, just using a bit of magic for this demonstration today, this map actually is linking to the 3 data sets that I've just migrated to my cloud database. So I can view my incident data, I can view my planning application data, and I can also view my brownfield register data as well. And within WebMap, we can interrogate that data. So I can perhaps click on that particular brownfield site, and on the left-hand side, we can see all of the attribute data that is available for that. Now, any changes you do make to the data, whether it's the geometry or the attributes, then those changes will dynamically feed into your web mapping application. So I'm just going to show you one quick example. So at the moment, if we look at the data on the left-hand side, the permission column, let's change that. There we go. It's that permission column there. And the status of this brownfield register site is currently application submitted. But that status has actually now changed. So let's just close that dialog for now. I'm going to return back to the desktop GIS where we're viewing the brownfield register from the cloud database. I'm going to select the feature. I'm going to view the properties for that feature, and I'm going to update the status. So rather than having application submitted, let's just say it's had full planning permission. And then when I commit that change is written back to the cloud database immediately. So if I now return back to the web mapping application and interrogate that brownfield register site in the web map, we can immediately see that change is reflected within WebMap. So we can now see the status of full planning permission for that feature. And that's just, just a really good example to show, how your data and your GIS software can be sort of streamlined in that cloud environment. And that also just brings it into my demonstration this morning. So sort of showed you how you can streamline your data as part of that sort of data migration process into the cloud. Just some of the factors to consider just to make sure your data is fit for purpose. So looking at geometry errors and attribute errors, and then just some of the tools that are available to migrate the data, whether that be manually via a desktop GIS or using an automated tool. So yeah, thank you for watching my demonstration, and I'm going to hand you back to Demelza.
Yeah, thank you very much, Simon. Really interesting to see all of the different tools and techniques available within the software. Okay, in summary, just to run through some key takeaways from today's session. Really, there are many benefits of cloud migration, but as we've seen, there are various data considerations and possibly challenges for you. Hopefully we've shown you that CADCorp can guide you based on a wealth of experience with other customers, and we can provide you best practices and ways for quick wins. We can help you decide on a best fit cloud migration model for your organization by running what's called a cloud migration review, where we can discuss in more detail how best to approach any cloud migration with you and your team. And CADCorp can provide data services, consultancy, software and training to assist in any cloud migration also. If you're interested in finding out more, you can search for Cloud Webinar on cadcorp.com and you'll find some complimentary webinars available. If you're interested in more personal discussion, there's a contact me option on the pop-up when you exit in the exit questionnaire today. Finally, I said we'd come to questions. Simon and I will just turn on our webcams such that we can take a look at your questions. Feel free to carry on typing your questions. We've got a few come in, so we'll start with those. A couple to start with for Simon, so I'll head straight to you, Simon. First one from Matthew. We have several hundred data sets. Is it possible to, when automating uploads, to clean the data as part of the process? Great question. Over to you, Simon.
Yeah, thank you for the question, Matthew. Yep, it is possible to automate the upload of multiple data sets and sort of clean the data as well as part of that process. I probably would recommend sort of a Python script as the approach for that. We have done something similar with one of our customers before. They had sort of a Python script, and we used that to take data from an Oracle database. We used some of the cleaning tools that are available within our technology to clean the data. And then at the end of that process, the data was exported to a cloud database, I think it was SQL Server in that instance. So yeah, I'd recommend sort of a Python script in that scenario.
Great, Simon, thank you. Another one for you from Jill. Using the ETL tool, is it possible to only upload new records rather than uploading the whole file each time?
Yep. So the simple answer is yes. So yep, you can upload new records to the database rather than just replacing the file every time. Yeah, the ETL tool has what we call an append option. So yeah, you can append new data to an existing table, and it does have loads of other functions which I didn't really have time to sort of demonstrate in detail today. One of them includes sort of an export option as well. So your data is in the database in the cloud, but you still have a requirement to have maybe a GIS file to be used locally or to distribute to another organization or partner perhaps. You can use sort of an export option to create a GIS file to a schedule from the data in your database. And probably worth mentioning, we do also have sort of a video on our CADCorp YouTube channel as well, which goes into the ETL tool in a bit more detail, so it'd be worth checking out as well.
Great, thank you, Simon. We've got a question from Gregory. Do we still need GIS desktop on a local PC, or does this sit in the cloud? I can pick up that one. I think for any migration, any data migration, we'd probably recommend that you do have a desktop on a local PC. But once the data is migrated, you could certainly use desktop from the cloud. Then you would be cloud to cloud to a spatial database perhaps. So that would be a good way of moving all software, if you like, into the cloud in future, as well as the data as well. We've got one final question here from Graham. I'll pick up this one as well. Can customers migrate to their own cloud environment? Yes, of course. We have customers utilizing AWS and Amazon and Azure, sorry, and they manage their own software and data there. So yes, it's perfectly possible as well. Okay, right, we're coming to a close for today's session. If you have any more questions, please complete them in the questionnaire when you exit today. Thank you very much, and we look forward to you joining us on future webinars. Thank you for attending today. Have a good day.